Hi, so we are going to solve the LeetCode problems based on topic. So for example, for the first topic, I have chosen linked list. We will solve a few problems from this category so that if you want to get proficient in some category, you will have a list of problems that you should solve in order to get better in that category. And solving just one problem won't get you anywhere in any category. And if you just watch the movie, watch the clip, and you do not solve it yourself, again, nothing is going to happen because no one in the world has become a good problem solver by reading books or watching YouTube clips. You have to take your pen and paper and try to solve the problem and then write the code. That's how you get better in problem solving. So for the first problem, we have two sorted lists and we want to merge them as you see, and we do not want to create new nodes. We just want to use the same nodes and put them in a sorted final linked list. So let me draw the example 1, 2, 4, 1, 3, 4. So we have here 1, which is pointing to 2, which is pointing to 4. Yeah, 4. And then we have 1, 3, and 4. Yeah, 1, 3, and 4. So what we will do, let's call this A, and let's call this, and let's call this B. So at first, when you're solving a problem, do not think about code. Solving the problem and understanding how it should work is not about code because maybe you don't want to write the code. Maybe you want to write the code in different languages at different times. So trying to understand the procedure, the algorithm is more important than writing the code. So let's say we have since both of these are sorted, so the first element of the result is either this or this, right? The result. So in this case, because they are equal, we will just take the first element of A. So we put A here, we put that 1 here, and we just get rid of this actually, and we move this one step forward. So we go and stay here. Again, we compare these two. Which one is smaller? This one. So we put that here. Actually, we set this is the next attribute. As you can see here, this is the next attribute. So we set the next of this one to be 1. And then we get rid of this and we move this one step to the right. So again, this is the next attribute, so we have here. Okay, now between 2 and 3 we take 2, we put 2 here. As you can see, we have two iterators, one which is working on A and one which is working on B, and we are moving one of them at each step. If A is smaller, we move that. If B is smaller, we move that. So here we are moving this. So and here, yeah. And then between 3 and 4, which one is smaller? 3 is smaller, so we put 3 here. And we get rid of this. We go and stay on the next. Now we have this 4 and this 4. We take the first one from A actually. This is 4. We get rid of this. And because A is now none, actually there's nothing else here. It's finished. So everything that is remaining from the second one, so for example, let's say we have 4, we have 8, we have 10. Whatever remains here in B, when A is none, A has nothing else, all of them go to the end of this result list. So we have 4, then we have 8, and then we have 10. So here we do not have any decisions because A is empty and B has 3 items, which all of them will go to the end of the to the end of this result linked list. So let's see how we can do it in here by code. So I will call them A and B, as you see. So we have some, so in order to start, we need to take care of edge cases. What does that mean? So for example, if A is none or B is none, if A is empty or B is empty, so what happens in this case? So if A is none, we return B, right? It doesn't matter if B is none or not. A is none, it means that the result is the whole B. Okay, so if B is none, we return A, right? So would you think about the case when both of them are none? What happens? Both A and B are empty. What happens? We will get to this if, right? And we will return an empty linked list, which is B. So if both of them are none, both of them are empty, we will handle that. If one of them is empty, we will handle that as well. So when we get to this line of code, it means that neither A nor B is empty. So both of them have at least one element. So we will define the result to be none. So if A dot val is less than B dot val, right? So result is A. And then we move A to the next one. So A equals actually A dot next. Else result equals B, B equals B dot next. At this point, we have created the result linked list, and actually we have chosen the first element to be from A or B. So from now on, we will do it in a while loop because the first element is fixed. So while A is not none and B is not none, while both of them have at least one element, here we will decide what to do. Take the next element from A or the next element from B. So we have the same, actually the same if else. So if A dot val is less than B dot val, we will take that from A, otherwise we'll take that from B. So here result dot next equals A instead of result. You know, we need to link, we need to tell to the result, hey result, would you please point to A? And then after we have pointed to A, we will move A one cell to the right. All right, and again here result dot next equals B. But at the end here we have set result to point to A or B. We need to move result one step forward. You see here what I didn't describe is that result was here, then we moved it here, then we moved it here, because we need this next to be set, you see. Then we move result one step to the right at each step. So we need to tell to result, hey, would you go and stay and point to your next value? So here result has some next, right? It's either B or A or B, okay? But after we have set the next of result, we need to tell to result, hey, would you go to the last element? So result dot result equals result dot next. All right. So here, when we get out of this while, the while loop is done. We are finished here. We at each step we take one element from A or from B, and we move forward until one of them becomes empty. When one of them becomes empty, the rest of the result is obvious. You see, so here all of these three elements should go to the end of result. So we tell result. We tell if A is none, result dot next equals B, else B is none, result dot next equals A. So here B points to the rest of the second linked list. It's not just one item. It's one item that has the rest of the linked list in it. So when we say, hey, result.next, you should now point to B. B is the beginning of the rest of that linked list. So we do not need to iterate because the links are there for us. You see here? So this is in place. We have this. We just need to tell next, hey, next, you should point to this next of the result. If that points to this here, then we have this one, and we have this one. All right? And the same thing happens here. If B is none, the result that next is A. And at the end, we need to return the head of the result linked list. But as you see, we have moved the result. You see now result is pointing to, for example, to this 4. But what we need to return is this one, the first element of the result linked list. So in order to do that, do you remember when we created the first element of the result? It was here. After we create the first element, before we move result one step to the right, before anything like that happens, we just need to have a copy of a reference actually to the first element of this result. So head equals result. And at the end here, we return just head. All right. And then we run the code. Hopefully it will compile and run. Yes, as you see, the sample works, and then we submit the result, and yeah, it's fine. So at this point, what I'm expecting you to do is to take your pen and paper and try to solve the problem first on paper, here, like this, on paper, and after you understand what is happening, what these two iterators are doing, they go to the right, they compare to themselves, to each other, and one of them goes to the right. After you understand this approach, then start coding. And never ever start coding before you understand what you want to code, because as soon as you jump into the code, you stop thinking. That's a fact. When you're typing, you do not think, you just want to type. And if you want to think in the middle of typing the code, it would take you at least twice to write the code, comparing to the other situation that you solve the problem, you understand the approach, and then you start coding. All right, so please do this. That's how it works, and hopefully you will solve a lot of these problems and improve in this category.